Hi everyone, my name is Alexander Khvorov, I work at JetBrains, and today I'm going to talk about STRM, Siamese Stack Trace Similarity Measure. Software products sometimes crash. The best way to handle crash is to send crash reports to developers so they analyze the reports and fix the bugs that produce them. But then it can be too hard when the number of reports reaches thousands. If a product is popular, one particular bug can occur in thousands of computers and produce a lot of similar but not completely identical reports. We can help developers by grouping similar reports into buckets. Reports are usually generated automatically and consist mostly of the stack trace. Some information about operation system and products can be included. When new reports come into the system, we should find the most suitable bucket for it. For this purpose, the report similarity model computes its distance to all reports and chooses the bucket with the nearest one. Most of the papers use TF-IDF for some variants of edit distance to compute the similarity between stack traces. Some of them also have selectable hyperparameters. We can call such approach classic machine learning. But the quality of all these methods is not perfect, and this makes a difference for big production systems like IntelliJ IDEA. Also, not a single work uses a real machine learning and especially neural networks, which can consider more complicated dependencies in data than classic approaches. To address both of these problems, we propose a Siamese architecture based on LSTM. It splits each stack trace on tokens and maps each token to a learnable embedding vector. Then one recurrent bidirectional LSTM network accepts embeddings of each stack and returns full stack trace vector representations. From these two vectors, we build one feature vectors and apply a two-layer fully connected network. By default, the tokens are method names, but we can trim them to class or package. We investigate the impact of trimming in our experiments. We use two datasets for evaluation. The first one is proprietary manually labeled datasets of JetBrains, and the second one consists of open source NetBeans data. We measured two metrics that are used in almost all of the papers on this topic: mean reciprocal rank and recall rate at top k. We compared our approach with the state-of-the-art methods on this task and compared models with different trimming lengths. Our methods surpass all baselines on both JetBrains and NetBeans datasets. For the JetBrains data, trimming is not needed as its influence on the result is small. For NetBeans data, it's better to trim methods to class level. However, the best score on recall rate at 10 was reached with the trimming to package level. Stronger trimming degrades the quality. It can be seen that STRM significantly outperforms all the work reviewed on both datasets, including our previous tracing work.